Hello and welcome back to the Tin Barn. I'm Pragmatic Lee, and in today's video we're going to try to take this square peg and stick it in a round hole. Or in other words, we're going to try to take this power feed, X-axis power feed designed for a Bridgeport mill or Bridgeport clone size mill and put it on this desktop or bench top Precision Matthews 727 mill. Get the camera a little closer and I'll show you a few of the obstacles we've got to overcome. Those of you familiar with my channel probably already know that I've got a power feed on this PM 727 mill now. This is one that I built myself. I didn't actually video building and installing this one, but I did do a video on the equivalent of this that I built for my or put on my X2 mill, little small X2 mill. I'll try to put a card up here to that video so you get an idea of that. This has served me well for about 4 years. I put this on within days of getting this mill, and it served me well, but there's always been a couple of issues with it. Number one was its rapid traverse just really isn't that fast. It took a full minute to get from one side to the other at the full speed. I can live with that, and I have lived with it for 4 years, but what has happened now, which is probably a combination of the drive here, the speed regulator and direction regulator, and the little bitty motor itself, is that it's getting very weak. I can start making a cut and then the motor will just stall out, and I keep having to add speed till I'm up. When I first started this, I'd run at about 30% of the motor speed, and it would make a nice cut with a rough and end mill with no problem. Now 30%, it stalls out immediately. I have to bump this up to 70 or 80%, and then what happens, the motor will surge, and if I got a small end mill in there, it'll break that end mill, or it'll just stall again entirely. So it's time to retire this little rig and put something with a little more horsepower on the mill. Now I didn't search the entire web, go to the end of the web, but I did look to try to find something a little smaller than this. This is a Wending. Yeah, I said that right, W-E-N-D-I-N-G. About $120 unit, $130 unit off of Amazon. It's made for Bridgeport and Bridgeport clones, but I could not find anything that was smaller, meant for benchtop, tabletop mills. So we're going to try to adapt this one today, and as I said in the introduction, there's a few obstacles we've got to overcome. Number one, this is the size of the lead screw bracket. This was the one that was on this end. This is the size off of this mill. This is the size of the one that comes with this power feed. We can overcome that. Another issue, which all of you, if anyone else tries this, you're going to face this as well. If you're using a stand wider than the base of the mill, and the pan that comes with the mill itself is even larger. But this distance right here versus what this will be when it hangs on there. See this? So we've got to get some separation between the mill itself and the table. I measured this. I've done some preliminary work on this off camera, and I've measured this, and I need just a little less than 4 inches more height in between. So that means I've got to lift the mill up 4 inches off the table. Now, is that going to put this way up here? Well, let me tilt the camera down just a little bit and show you in my situation. This table that I used to put this mill on, I've already got, it was too low for what I wanted to begin with. So I've already got 3 inches right here and some channel iron welded together, raise the table up. And also in these feet, adjustable feet that I put in here, I can probably get a 1/2 inch out there, recover maybe a 1/2 inch. So what that means is I should be able to hold this table at within 1 inch of its current height, which I wouldn't care if it was a little higher, but I should be able to hold it at its current height and drop the table down. So I'm going to do that off camera. A couple things I'm going to do off camera is get this jacked up, and what we will use, I have pedestals already made, 4 of them that will go between the mill and the table out of this 1-inch pipe. But I'll get that done. I'll get this drive off, and then we'll start looking at the actual installation and a couple of other obstacles that we have to overcome to make this fit the lead screw on the mill. Okay, I'm not sure what kind of mushrooms I was munching on when I come up with the idea of using pipes as pedestals to raise that up, but this is hollow under here. About a 1/2 inch lip all the way around and some webbing in there, but obviously I was way short. So what I did was take the spacers that I had under the legs, brought them up here, added a piece of 1/2 inch channel, and I took the table out from under it. That gave me almost 1 inch right here in height. So with this combination right here, I've got the table up, or I've got the mill up high enough that the drive will clear this. I may do that a little bit different later, just according to how this settles. I've got the table sturdy now, got the mill with just a little bit of a downhill on it to facilitate draining. So let's get started actually putting the drive on. Remove this handle assembly. And by the way, when I get all this put together, I have no idea I'll be able to get this handle back on and use it. We'll look when we get a little bit closer, but if I don't, it's no big deal. I'm left-handed to begin with, so the handle that I've put back on the other end down there, you can see now, it's back on there. I took the drive off that I had made. It won't break my heart at all if I'm not able to put this handle back on here. If I am, fine, but if it causes a lot more modification that I want to do, then I'll just leave it as it is. And by the way, as well, I plan to do as little modification to the mill as possible. If I've got my ducks in a row, the only thing I'll have to do is drill a couple of holes right here to mount this mounting flange with. Now this has, of course, a keyway. Also has some thrust bearings in this end as well. Try to keep all this stuff together. In addition to these 4 screws that was in there, socket head cap screws, there's 2 pins, alignment pins. Like I say, there's 2 sets of thrust bearings in here. I'm going to keep all together. This washer right here appears to be pressed on. I I will not be bearing against that, so I'm just going to leave that on. Now again, this drive is supposed to work with Bridgeports and Bridgeport clones. And when I ordered it, it said that it would work with any mill that had a 5/8 inch shaft lead screw. I'm not sure where that comes from, because nothing about this is 5/8. This is the bushing that came with it that fits in here. And if I measure that in inches, I'm getting 0.788, which doesn't, to me, doesn't come up to any nominal imperial size. It's actually 20 millimeter. Now the lead screw on mine is 17 millimeter, exactly 17 millimeter. So the bushing that came with it is not going to work. Thankfully, this shaft is smaller. What I did off camera was, out of some stainless steel round stock, I made a new bushing that will fit on the shaft, 17 millimeter internal, and I don't remember what that external was. Let's see, 24 millimeter. But before we hang this on there, let's go ahead and mount the bracket on so we can see where to mark our holes. This bracket is actually keyed onto this power head as well. Now with the bushing that I say I machined off camera, I wouldn't be near as tired in the evenings when I go back in the house if I didn't drop so much stuff. Now between that thrust washer that was left on there, on the shaft, and the bushing that I made, there's a little space in there. So I'm going to have to make a bushing to go in that as well. But for right now, let me get this level and clamped in place, and we'll see if we can mark and drill a couple holes. Now while everything is in place, I'm going to try to put me a little Sharpie mark just as close up to that bushing as I can. Then when I take it off, I know the length of my bushing, or I will know the length of my bushing. I can measure between this Sharpie mark and that thrust washer that was left back here, and from there come up with a bushing. The original kit, let me show you a little bit. The original kit come with a double handful of these spacer washers. But remember, there's 3 millimeters difference between my shaft and these. So I have made a few, made up a few myself. And again, I'll measure that distance. And there's a little play in here, a little bit of room I can play with. That is 31 millimeter, and this is 16 and a half. So let me make a note of that. So I will need about a 14 millimeter spacer to go in there. Right now, I want to drill and tap these holes. And that spacer will just keep that from wandering in. It's not going to come out because we're going to have the pinion gear on this side. But I don't want it to to wander in, like for it to stay center. Okay, for now I'm going to go ahead and mount this on before I make that bushing or make that sleeve, because we got some other work we're going to have to do on the lathe as well. And I'm going to go back with the same screws that came out of the original here. Looks like I could probably use some just a little bit longer, but this will be good enough to get the measurement we need next. All right, I'm going to see if I can get the camera zoomed in a little bit for you. All right, the way these drives work, as you see, here's a gear that comes straight off the gear motor. This shaft, or this pinion, I guess you'd call it, rack and pinion, not sure, bevel gear, goes over that and meshes with this. But there's a problem. This is not big enough. I'm sorry. The hole in this is the 13 millimeter as well, and this is the 17 millimeter. So what we've got to do is carry this over to the lathe, and all this mechanism right here, this plastic nut and this spring washer, is to hold the scales for the again, for the Bridgeport style. But we're going to mill this, or we're going to bore this out to this size. Then we're going to have to cut this off. When we got it where it'll fit on, we'll come back over here and measure and see what is necessary to for the length, and then the nut to go on the end. So let's turn over to the lathe and start boring this out. Remember what I said, folks. We're putting a square peg in a round hole. We're making something meant for a much, much different machine work on this much smaller machine. Okay, just did some measuring on this, and this is where the 5/8 comes in. I'm never seen the end of a Bridgeport with the handle off of it, so I don't really know how all this would have worked on it. But this is the 5/8 that needs to go out to the 17 millimeters, which means we only got just about 1.2, 1.1, 1.2 millimeters to take off of this. So I'm going to have to take this very slow and easy. And before I even started this project, off camera I made a 17 millimeter piece of stock here just to use as a test gauge. Alright, so let's touch off, and I'll try my best not to get in the way of the camera. This is going to be an interrupted cut because there is a keyway inside this piece. I'm not sure if I got my DRO in millimeters or inches. Alright, that's in inches now, so I'll go back to millimeter. So that's a 1/2 millimeter I'm going to take to begin with. This will be a total of 1 millimeter. Shows like 0.4, so I'm going to try. That was another 0.3 millimeter. Make just a spring pass with that same setting. There we go. I'm happy with that. Now I'm going to carry this over to the, well, let me put the camera on there and then you can see what I'm going to do. Okay, I brushed off some of the brass filings there. Before I put this together permanently, I'll carry this over to the parts washer, wash all that grease and filings out, swarf out, then put some fresh grease in. What we want to do right now, we're going to cut this off so that the overall length is right here at the end of these threads. The ends of those threads is 36.37 millimeters from the end. So at that mark is where we're going to part it off. All this down here will be waste. Remember, square peg, round hole. What we'll have to do as well, this shaft is keyed. And that keyway was a whole lot smaller than that. But we'll have to broach this out for the same size key. But I'm going to go back to the lathe now and part this off. I may have to extend that blade out a whole lot more than I want to. That's a whole lot more parting blade out there than I would ever want to use, but we got to get past this gear flange. That should bear a length. If anything, might want just a hair long. Okay, folks, I don't think that's going to work with that blade stuck out there that far. Let me think about this just a little bit and we'll come right back. Okay, I'm going to try this parting tool off. Try this one instead of having that long stick out. This looks like it's got enough clearance to part that. We'll see here in just a minute. Alright, that got it parted. What we'll do next, I will turn over to the press. We'll get set up to broach this keyway out. Okay, turns out there's just way too much content to put this all in one video and keep it to a reasonable length. So I'm going to stop at this point. Uh, Stay tuned to the channel. Part 2 of this series will be out in just a few more days, probably about a week. And then we'll conclude this, this build or this project of the square peg in a round hole.